Hey guys, how's it going? In this video we're going to go over question 1 from the 2019 Specimen SQA Advanced Higher Physics exam paper. Now I should point out that this question 1 is actually the same as question 1 from the 2016 SQA Advanced Higher Physics paper. So if you've watched that video then there's no need to watch this one. I'm really only putting it here so that it can be included in the playlist for the 2019 Specimen exam paper. But if you haven't seen this question yet or just want a reminder, then feel free to stick around. Let's get into it. Now question 1 here shows a picture of a car on a racetrack, and it says a car on a long straight track accelerates from rest. The car's run begins at time t equals 0. Its velocity v at time t is given by the equation v equals 0.135 t squared plus 1.26 t, where v is measured in meters per second and t is measured in seconds. It then says using calculus methods for part A, determine the acceleration of the car at time t equals 15.0 seconds, and you can see there's 3 marks available. Well, remember in the question here we're given an expression for the velocity v in terms of time t, and we're asked to determine acceleration. So to go from velocity to acceleration we need to differentiate the velocity v with respect to time t. So we can use an equation from the relationship sheet which says that a equals dv by dt. That's the acceleration is equal to the rate of change of velocity. So that is the same as writing d by dt of 0.135 t squared plus 1.26 t. In other words, we're going to differentiate this expression with respect to time. So if we do that, remember to differentiate we need to bring the power down and multiply it by the front and then take away 1 from the power. So that means we have 2 times 0.135 times t plus 1.26. So we can simplify that to 0.27t plus 1.26. And because we're given a time value here, we can now substitute the time value into this expression for the acceleration to find the value for the acceleration. So we have a equals 0.27 times 15.0 plus 1.26, and putting that into your calculator should give you an answer of 5.31 meters per second squared. Part B says to determine the displacement of the car from its original position at this time, and again there's 3 marks available for this. Well, remember in the question we were given an expression for the velocity v, and we want to now determine displacement. So to go from velocity to displacement we need to integrate this time. So we're going to integrate velocity v with respect to time. So we have v equals ds by dt is equal to 0.135 t squared plus 1.26 t, where we're taking our equation from the relationship sheet v equals ds by dt, so that we can then just ignore this v and then deal with the ds by dt part and this right hand side. So we're going to integrate both of those. So we have the integral of ds by dt dt is equal to the integral of 0.135 t squared plus 1.26 t dt, where we're using brackets here to show that we're going to integrate both parts of this expression. So remember ds by dt is just our velocity v, so if we integrate velocity we get displacement. So we get s equals, and then to integrate these parts, remember we want to raise the power by 1 and divide by the new power. So we have 0.135 t cubed over 3 plus 1.26 t squared over 2 plus the constant c. And then let's simplify these fractions, so we have s equals 0.045 t cubed plus 0.63 t squared plus c. So as always we want to get rid of this constant, so we need to consider the initial conditions, which remember is what happens at time t equals 0. So we can say at t equals 0 the displacement s equals 0, in other words the car hasn't moved yet. So that means if we sub in t equals 0 into here as well as the s equals 0, that means we get c equals 0. So we can essentially rewrite this just without the constant there. So we have s is equal to 0.045 t cubed plus 0.63 t squared. And lastly we want to substitute the time value. We were told at this time, which is the 15.0 seconds from before. And lastly we want to substitute the time value. Well, we were told in part B that we're talking about at this time, which was just the time mentioned in part A, which was 15.0 seconds. So we can sub in our 15.0 seconds into here to say s equals 0.045 times 15.0 cubed plus 0.63 times 15.0 squared. And if you put that into your calculator then you should get an answer of 294 meters. That's all for this video folks, thanks for watching. If you made it to the end I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.